morning, dear students. Yesterday class we discussed about final control elements of final control operation, right? So in that we recall that the basic control system, which comprises a controller, a process, and feedback element, isn't it? Once again, so what is the basic control system comprises? A controller, a process, and a feedback element, isn't it? So when you open this controller, you can observe three basic blocks. Number one, signal conversion, actuator, and control final control element, isn't it? Right. So yesterday we discussed about signal conversions. So basically we have any type of signal, maybe electrical or non-electrical, may be converted into non-electrical or electrical as per our requirements. So we have to use a suitable converter, signal converter. So this process can be done with the help of available transistors, right? And as per our syllabus, we converted the current into pressure and pressure into current and and pneumatic. Pressure into pneumatic pressure into pneumatic pressure into a suitable electrical signal, voltage or current with the help of LVDT. So these three conversions are done with this signal conversion, right? And today we see the second block available in the controller, that is nothing but actuator. Actuator is nothing but is action or is a mechanism needed to drive the respective other element or other block, isn't it? See, the actuator, for example, I have a a control valve. I have a control valve. Control valve having a controller, nothing but for opening and closing purpose. So what can we control with this control valve? Or we can take a water tap, as we discussed yesterday night. So we take water tap. Water tap having a controller, it looks like a opening and closing purpose. Right? So I want to drive the a tap for opening and closing. I need a mechanism. Who can provide this? The actuator will provide. I need some mechanism or action for opening and closing the usual tap, water tap. That is the meaning of actuator. Mechanism we need it. Fine. Okay, what type of actuators we have as per our syllabus? There are number of actuators are available in the process industries, the industrial instrumentation side. Anyway, but as per the syllabus point of view, the actuators may be three types. Three types of actuators are available in the process control instrumentation subject. Basically, the first one is electrical actuators. Electrical actuators. The second one is pneumatic actuators. Lastly, hydraulic actuators. So these three we have to study and go through it, right? And it is very important question also, generally, right? So if you see if you observe the uh, the first uh, the first category of actuator, which is nothing but electrical actuator. You see the definition. You see the definition. Actuator, actuator, nothing but nothing but actuators converts the control signal into action. Into action. What is the control signal? The signal is coming from converters. Coming from converters, signal converters. So the output of signal converters is given as input to the actuator. So that input so-called control signal. So actuator converts the control signal into action The output of actuator is action or mechanism. The output of the actuator is action or mechanism on the control element. On the control element. So this is for example, see just now I discussed. If a valve is to be operated, then the actuator is a device that converts the control signal into physical action of opening and or closing the valve. This is the meaning of this. So actuator is needed for controlling opening and closing the control valve. First of all, we have electric actuator. We have electric actuator, right? Uh, in this electrical actuators, first of all, what is electrical actuator? Electrical actuator is a mechanism, is an action which converts or which converts electrical input into mechanical a mechanism, into electrical action. It converts electrical input into mechanical action. Mechanical action. Simply, the electric actuator accepts electrical signals as inputs and it will give the mechanism or action in terms of mechanical motion. Mechanical motion. The good example for this electrical actuator is solenoid. Solenoid. See this solenoid? A solenoid is a elementary device that converts an electrical signal into mechanical motion, usually in a straight line. It converts a straight line. See the diagram? This is the diagram of a solenoid. Solenoid is one example of electrical actuator. See what is the solenoid structure? Solenoid is it is looks like a horizontal. It's also called what is called plumber. I think so. Plumber it is. Yeah, plunger. I'm sorry, plunger. The horizontal one is a plunger having some this arrangement provided on this top with some coil excited by some electrical current as input. Excited by some electrical current, right? So if you apply any current to this, it will induce some field. It will some induced field inside the coil. Some field is induced in this coil. So because of this field, the plunger which is in the which is in this coil, the plunger may be sometimes in or sometimes out as per our input signal applied. So the plunger may be towards in or towards out. It can move like this. It can move like this. So what happens? The solenoid simply converts electrical signal into mechanical motion. Sometimes in, sometimes out. In and out continuously. That is called a solenoid is a good example for electrical uh, electrical actuator. Okay, I will tell you one more example. One more example is for the second example for the electrical actuator uh, is electrical motors. You know electrical motors? Motor, you know, DC motor, AC motor. You know what is a motor? Motor is a motor is a device converts electrical signals into mechanical output. Mechanical output. So what is the mechanical output expected from the motor? Rotational displacement. Rotational displacement or speed. So you take any DC motor or you can take any AC motor. By the application of the input electrical signal, we can convert the speed of the motor, the torque. Thereby, we can control the speed of the torque. Isn't it? So the speed of the rotor is directly proportional to applied electrical signal. This is the second example for electrical actuator. What is the second example? Motors, electrical motors, that may be DC motor or AC motor. Sometimes, that is so called stepper motors, stepper motors. So if you apply electrical signal to this stepper motor, what is the output? What is the output? Again, a rotational displacement. Rotational displacement. But remember, the output of the stepper motor rotational displacement is not continuous. It is stepwise. Stepwise rotational displacements we are expecting, right? So stepwise rotational displacements. That is output of a stepper motor. So under this electrical actuator, the first example is solenoid. Solenoid converts electrical signals into mechanical motion in and out with the help of plugger. Second example is electrical motors. That may be DC motor, that may be AC motor, that may be sometimes stepper motor. Stepper motor. These draw this diagram for this is about the electrical actuator. Electrical actuator simply converts electrical signals into mechanical motions. And we'll see one more pneumatic actuators. Pneumatic actuator. So what is pneumatic actuator? Pneumatic actuators may operate directly from the pneumatic output signal from a pneumatic controller, or they may employ a separate source of compressed air. Generally, where should we provide actuator? Tell me. In the complete control system diagram, there is a controller. If you open the controller, we can see three blocks. One is one is converter, second one is actuator, next one is final controlment. So in the so after the converter, signal converter, we are providing actuator, right? So if it is electrical actuator, the output of signal converter should be electrical. Remember, we are provided actuator after the block of signal converter. Is it clear? So if it is an electrical actuator, what is the input to the electrical actuator? Electrical signal. Who can give the electrical input? The signal converter is to be given the electrical input. Then what is our input to the signal converter then? Non-electrical. Non-electrical. So the signal converter, if I place a electrical actuator in my diagram, I have to give non-electrical input to the signal converter. I have to convert into electrical. That electrical given to the electrical actuator. But if I place a pneumatic actuator in my diagram, pneumatic actuator accepts air inputs or pressure inputs, air inputs, pneumatic inputs. So who can give the pneumatic inputs? The signal converter, the output of signal converter is pneumatic signal, air signal. Pneumatic means air signal. That output given to the pneumatic actuator. But what is the input to the signal converter? If it is pneumatic means non-electrical, that should be electrical. That should be electrical. So as per our requirement, by by selection of this actuator, we have to modify the input and output signals, right? And pneumatic converter simply converts pneumatic signals into some suitable mechanism. So the principle is based on the concept of pressure as force per unit area. That means it may be accept air pressure. See, if the net pressure is, if you apply difference of the pressure to a diaphragm source of area, net force acting is F equal to P2 minus P1 by into force per by A. By is missing here. P2 minus P1 by A. So, what is there in the pneumatic actuator? Recalling once again. In the pneumatic actuator, for the pneumatic actuator, the input is pressure. You can apply simple pressure P, or you can apply difference pressures P1, P2, or difference in the two pressures. You can apply. There is arrangement for applying the difference pressure for the pneumatic actuator. No doubt. If you apply pneumatic pressure to the pneumatic actuator, it converts into force. It converts into force. What is a force? Force is a mechanical motion. Mechanical motion. So this mechanical motion will drive will drive the that is called um, diaphragm. Diaphragm. What is a diaphragm? Diaphragm is elastic member. Is elastic member. So when force is applied on the diaphragm, what happens? The diaphragm will be moved. There is a moment. So when the diaphragm will experience any force from the output of pneumatic actuator, the diaphragm may take some moment uh, like this. So because of that moment, what happens? Some mechanism is existed for the next device, next section. So the wall for the complete pneumatic actuator, the wall will be opened or closed. So that is a needed. That is needed. So I want to open or close other section. So in order to open and close that one, I am using a diaphragm. So who can move the diaphragm for opening and closing purpose or any changing purpose? I need some mechanism that is the help of pneumatic actuator. Okay, that's about the pneumatic actuator. Yeah, very good. Yeah, see this, observe this, observe this. Yeah, pneumatic actuator in low pressure state. So this is a diaphragm. Observe all of you, dear students, observe this diagram. Observe this. So it is input pressure. Input pressure. It is a hole. It is a spring. These are diaphragm. Diaphragm. So where because of because of output of actuator, output of the signal converter, that is nothing but air signal. That is given to pressure input. That is nothing but pressure input. If I give the pressure input from a signal converter, that will fall on the diaphragm. This is the diaphragm that will fall. So this pressure will fall on this force. It experiences a force, isn't it? So diaphragm may move towards down. May move towards down or towards up as per the direction of the pressure input, air input, isn't it? So how this diaphragm is going to move towards up and down? Some spring damping is provided. Some spring is provided. The spring will provide some damping for the moment. That means the diaphragm may move like this, towards up or towards down. So this horizontal diaphragm may connect it to other section. That section may be experience the needed mechanism. Whatever the mechanism needed, it will experience through the diaphragm. That is happening in the case of pneumatic actuator. Pneumatic actuator simply converts the air pressure into mechanical force with the help of a diaphragm. Right? Yeah, see, that is low pressure. In high pressure, see the shape of the diaphragm is reversed. Shape of the diaphragm is reversed. See in the diagram, in the low pressure, diaphragm position is like this. Diaphragm position is like this. But in the high pressure, if you apply high pressure as input to the to this in the actuator, see the position of the diaphragm is modified. This is the position of the diaphragm. Okay, anyway, you can convert air pressure into mechanical force through this diaphragm. This is about pneumatic actuator. And one more is hydraulic actuator. Next one is hydraulic actuator. Hydraulic actuator simply converts there is a need to convert hydraulic levels. Hydraulic means fluid levels. One level of fluid into another level of fluid. One level of fluid into another level of fluid. It is done with the help of hydraulic actuator. Okay, this is about your actuators, actuators, right? And uh, now I am going to. Do you have any doubts regarding this? If you have any doubts regarding, dear students, if you have any doubts regarding this actuators, means electrical actuator, and is, I mean, the pneumatic actuators or hydraulic actuators, right? So, I will give you the material, no doubt, no problem. Right? You have to, it is very simple to understand. Simply a conversion, isn't it? Um, so, we convert mechanical to mechanical, electrical to mechanical, mechanical to electrical, like this. So, strictly speaking, all these actuators make you mechanical output. Mechanical output. You take electrical actuator or pneumatic actuator or hydraulic actuator, all comes under mechanical output, no doubt. But input may be changed. Input may be electrical sometimes. Input may be air pressure, maybe sometimes hydraulic levels. Input may be non-electrical or electrical, but output of this actuator is always this mechanical part. Right? Now I am going to stop here this class, and so in the